This video is to demonstrate that expanding Earth theory is true. The continental crust has a greater than 99% fit together on a smaller sphere, on a smaller globe, on a smaller Earth. And it is a conclusive geometric proof that the Earth has expanded. And I'm going to present a short, reasonably short video demonstrating how you could at home also replicate that the Earth has expanded based on the continental boundaries having a greater than 99% fit together. I was not able to achieve that percentage in this video. James Maxlow, an Australian geologist, he has done 23 reconstructions of the Earth, and he has achieved a greater than 99% fit together. I'm just using plasticine. My techniques aren't as controlled as his measurements would have been and as his experiment would have been. So the purpose of this is just to demonstrate how anyone at home could replicate these results. So what we have here is a 20 centimeter globe, and if I just go to this this sphere here is 150 millimeters or 15 centimeters, and it's I've used a polystyrene ball, and I've just simply taken the continental crust that was on the 20 centimeter globe and placed it onto the 15 centimeter globe. Okay, the information that I'm using has come from this map here. Essentially, the white areas are continental crust that's above sea level, and the yellow plasticine represents submerged continental crust. And you can see from this map that this area here, for example, would be submerged continental crust. These light grey areas around the edges. And so here, South America, you can see submerged continental crust, and likewise it has been reproduced on here. Now I'll just go to my reference. This is a map that was done in 1996. A more recent map has been done in 2008, but the 2008 version doesn't have the spinning globe that you saw previously, and that's why I'm using this map. Just briefly, as you can see, these areas here have fault lines, and that's where oceanic material is formed. New oceanic material is formed at these fault lines, and that increases the surface of the Earth, and therefore increases the radius of the Earth. As you can see from this legend, red represents oceanic crust which is less than 10 million years old, and blue represents oceanic crust which is 180 million years old. Now the 2008 version of the map, they've re-established that the oceanic crust is up to 250 million years old, and they have a purple scale that goes beyond this blue scale. And what that all means is that because the continental crust is believed to be approximately 4.6 billion years old, and the oceanic crust is only up to 250 million years old, what that means is that the oceanic crust is relatively new to the Earth. It is at the very most only 6% of the age of the Earth according to these maps. So basically I'm just going to walk you through what I'm representing on this globe so that you can clearly see that I've included all the continental crust submerged and as well as above sea level. So first of all we have Antarctica. This dot here represents the pole, the South Pole. As you can see here, we've got a tail to Antarctica which touches the tail of South America, and that's the same configuration shown on the map by the National Oceanic Atmospheric Administration. So I'll just play this, and it just basically I rotate through showing all the continental crusts. Okay, so we've got New Zealand coming up now. I'll just update this map. So we've got New Zealand shown out to the east coast of Australia, and we've got Australia coming up. As can be clearly seen, this is an expansion joint, and as new oceanic material is formed at this ridge line, it has pushed the continental crust away in that direction and pushed the continental crust away in that direction. So you can see that this part of Australia fits down into this area, that curved part of Australia fits onto this curved part of Antarctica. Okay, so we have Madagascar and we have Africa, South Africa. Let's update the map. So we have Madagascar and South Africa shown there. Alright, back around to South America. As you can see here, there's South America shown on the map, on the spinning globe map, and we've got submerged continental crust out to the east, and likewise we have submerged continental crust shown out to the east of South America. Okay, now this big region here you may not be familiar with, that is submerged continental crust. Once again, here's New Zealand, here's Australia. Just update the map so that you can see that. So as you can clearly see, we have submerged continental crust. It's definitely not oceanic crust based on its age. And please note that this little part of oceanic crust shown here, I have not replicated that on my model. I overlooked that. However, this small region here is shown adjacent to Papua New Guinea. So once again we have oceanic crust being shown in this expressed area, and as you can see there's coloured sections that represent oceanic crust in between the continental crust and the submerged continental crust. So submerged continental crust and continental crust which is above sea level. Back around to Africa and Madagascar. Back around to South America. Red line showing the equator. Okay, so we have Papua New Guinea there. We have Borneo, Indonesia, the Philippines. So this is Southeast Asia. Up here we have India and Sri Lanka. Now I'll just update this map. So obviously previously there's Borneo, Indonesia, Philippines, Malaysia. We'll just move it to India. So Sri Lanka, India, and you can see here we've got this light grey area which is representing submerged continental crust, and likewise here submerged continental crust. So back around to Africa. and South America. Okay, so we've got Japan up here. I believe it's the Mariana Trench. It's located off the coast of Japan, which is the deepest trench in the world. Okay, so we've got India again. Himalayas would be here. We've got Saudi Arabia, the Horn of Africa, the Red Sea. We've got the Mediterranean, the northern part of Africa. I'll just update this map. So as you can see, we've got the Red Sea there, Saudi Arabia, the Horn of Africa, the Mediterranean, northern Africa. Okay, so we've got the Caribbean, we've got Mexico. As you can see on this map, we've got the Caribbean, Mexico. You can see it's all submerged continental crust in those areas. So once again, we've got Saudi Arabia, the Red Sea, the Mediterranean. You can clearly see this outline here meets with that outline there. So we've got North America, Japan, Southeast Asia, China. So this outline here on Africa meets up with this outline here on South America. Just move it forward. So we've got Canada coming up. So we've got Canada up here. We've got Alaska coming up and Russia in the background. So Canada, Alaska, we've got Russia. So we've got Russia here, China, Russia extending back out this way. Okay, so Iceland has actually slipped off its location. That's meant to be Iceland there. Let's update this. So Iceland is seen here. We've got Greenland. Greenland is shown here. We've got England. England is shown here. We've got France, Spain. So France here, Spain there, Mediterranean there. And here we have the North Pole shown by that dot. And if I just move the map forward, as you can see, there's continental crust in that area there. The Earth is essentially top heavy. Most of the continental crust is in the northern hemisphere. So now we'll go to the 15 centimetre globe, and I'll just reverse this back to the start. We've got Australia at the top with Antarctica below, centered. Likewise, we have Antarctica shown here, Australia is above, Madagascar is here, Africa is here, the tail of South America is here. So I'll just play this forward. So it's like as if Antarctica twists as the Earth has expanded. This lower section of the Earth has twisted. Okay, so you can see Australia up here in this section. So we've got Papua New Guinea. Just move the map forward. So Australia shown here. Australia's there. Now this blue area is oceanic crust, which is still existing at this time because the 150 millimeter globe or 15 centimeter globe is 75% of a 20 centimeter globe. So the scale of this is 75%, and I believe that if you continue to reduce remove the oceanic crust so that all the continental crust is touching, you can reduce it by 64%. I've done this simply because of the size of the polystyrene that was available, and just so that things don't become so blended that you can't distinguish what they are. So I intend to do another video with a smaller sphere again, but at this stage I just want to show what distinguishable features, and because as the Earth gets smaller, the distinguishing features are lost. So this oceanic crust here, you can see that this outline here, that it's going to meet with that outline there. And if I just take you to this point here, as you can see, this is oceanic crust that's aged and would still be present on this scaled version or of this pro rata sized Earth. So I understand that the oceanic crust, the shape of it there does not match the shape there. I can't explain that. Essentially, I put the landmass of Europe on first. Then I located Africa. Then I located South America and North America, because all those joints are quite obvious how they work. But it would appear that Australia, the way it has moved, it's gone from a location here and moved across towards Southeast Asia. So that may have resulted in deformation of the oceanic crust. My model was based on trying to achieve what would reasonably be considered the next step. So obviously this is a two-stage reconstruction. James Maxlow has done a 23-stage reconstruction, so it's very difficult to go in two stages to interpret correctly where things should be, but I believe I've got it fairly close. Okay, so we have Japan up there, China, Southeast Asia, so we have Borneo and Indonesia and Philippines and Malaysia, etc. Okay, so we're coming around to Madagascar and Africa. Just update this. So as you can see, there's blue, what has been dated as old oceanic crust by the blue colouring. We've got Madagascar and Africa. So that explains why I've got oceanic crust shown in blue here. I can't explain why I have oceanic crust still present in this area here. That's just the way it turned out. If we go to here, we can see that there's no blue oceanic crust being shown. So really, that area there, I would have expected that not to be present, but it is. But having said that, you can see that this boundary here will meet up with that boundary there, and that boundary there will close into that boundary there. You know, it's still feasible that these boundaries will meet up at this point. So you can't see it very well, but basically we've got the outline of Africa there and the outline of South America there, and we have submerged continental crust in between those two continents. So it would appear that there was a weak point through there, and that's why it broke open at that part. So we'll continue. So we have New Zealand here, and this is that big submerged continental crust to the east of Australia. So we've got Papua New Guinea and Australia. So I'll just update this. So we're just formally showing Papua New Guinea and Australia. Okay, so we've got Japan there, China and Russia. Once again, we'll just update this. So we've got Japan, China, India. And I believe that's India in that area there, with the submerged continental crust to the west. So we've got the Horn of Africa, the Red Sea, Saudi Arabia, Northern Africa coming up. Okay, we've got the Mediterranean shown here, North Africa here. So we've got Spain, France, England, Iceland, Greenland, and this blue area here. Just go to this map. We've got old oceanic crust here in blue and old oceanic crust here. So that means we're left with oceanic crust in that area, and you can clearly see that this boundary is going to meet up with that boundary there as it gets smaller. Okay, so we've got the Caribbean down here, Mexico, we've got North America, Canada, and we've got Alaska, and where it comes into contact with Russia. So we've got Japan there, and Southeast Asia there, India there, back around to Saudi Arabia, Red Sea, Horn of Africa, North Africa, and the Mediterranean. So France, Spain, England, Iceland, Greenland. We'll just update this. So Iceland, Greenland, England, Mediterranean, Spain, France. Okay, so that's Canada, and we've got North Pole being shown here. Just update this. So that is the top of America. So it's that area there. And that's the top of Russia. So that's that area there. Okay, so I believe that point there was the North Pole. There's Greenland. Okay, so that concludes my video, and as I said, you can replicate what I've done here using household items, plasticine, polystyrene, and a globe from a suitable store. And essentially I located the Continental crust in white plasticine first, and then scaled by eye using longitudinal and latitudinal lines on the globe as shown on my model, and the lines shown on this map. I was able to scale by eye where the submerged continental crust needed to be. So expanding Earth is, in my view, based on this evidence, is a conclusive geometric proof that the Earth has expanded. And the next question is, why or how? Thank you for listening.